Hello everyone, welcome to the solution of LeetCode problem 331 named Verify Preorder Serialization of a Binary Tree. In this problem, we are given a binary tree and its serialized version, and we have to determine whether this is a valid binary tree serialized version or not. So here, one way to serialize a binary tree is to use the preorder traversal. When we encounter a non-null value, we record the node's value. Otherwise, if it is a null value, we record using a sentinel value such as hash. So we are given a string of comma-separated value preorder, and we have to return true if it is a correct preorder traversal serialization of binary tree. And it is guaranteed that each comma-separated value in the string must be either an integer or a character hash representing null pointer. And here you may assume that the input format is always valid. For example, it would never contains two consecutive commas such as 1, 3. Now we do not have to construct any tree. We have to just determine whether the sequence is valid or not. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example. The root is 9, which has two children, 3 and 2. 3 has two children, 4 and 1. And 2 has one children, which is 6. And here, the another children which is missing in the node will be represented by the null. So here, let's first try to understand how basically this serialization string comes from this node. So here we are basically performing a preorder traversal. So in the preorder traversal, we have to process the root first. After that, we will process the left children. Then we will process the right children. So now let's understand how this serialized version comes from this tree. So in the preorder traversal, basically currently we are at this point 9. So 9 is presented here. After that, there will be a comma. Then we will process the left subtree, which is 3. After that, we will process the left subtree, which is 4. Then 4 has left subtree, which is null, so it is represented by hash. Again, 4 has another subtree, which is null, it is represented by hash. So the call will be in this node 3. So node 3 is processed here. Similarly, from the node 3, we will be at node 1. So node 1 and these two hash for its left and right children. Now, from 1, we will get back to 3. From 3, we will get back to 9. And from 9, we will get back to 2. This is 2. And for 2, it will be its null node. So it will be hash. And again, call will be in the root. From 2, it will be went into the 6. So there is 6. And these two hash is for their null children. Now we have to understand how this serialized version comes from the original tree. Now we have to determine either this serialized version is representation of a valid binary tree or not. So how can we do it? So far we have understood how this compressed string or the serialized string comes from this binary tree. Now we are given this string and we have to determine whether this string is the valid representation of a binary tree or not. So how can we do it? Simply, we have to run a loop from left to right, and if we find any of the comma into the iteration, that means before this comma, there is a valid node. So before this comma, there is a valid node 4, and before this comma, there is a valid node hash. So if we find a comma, that means we have found a valid node so far. So this is the basic intuition. Now let's dry run the example. Initially, we are at this node 9, so it is not comma, just ignore. Then we are at this comma, so initially the node value will be 1. As far as we have found comma, we have to decrease the node value to 0. Now we are at this value 3, just ignore it. Now again we are at this comma. That means we have found another node before comma. So here, but before that we have to do a check. That means when we are at this second iteration, that means first iteration actually, we have found a comma here. That means we have found a valid node before it. So 1 will be decremented to 0. Okay. Now, for this node 9, there can be two children of it. One is 3, another is 2. So our respected node value should be incremented by 2. Now we are at this node 3, so let's ignore. Now we are at this comma. That means we have found a valid node here. So 2 will be decremented by 1. But for this node 3, there should be 2 more children. So we have to increment 1, 2, 3. Now we are at this node 4. Ignore it. Now we are at this comma. So we have to decrement 3 from 2. And as 4 is a valid node value, that means it should have 2 children. One is left, another is right children. So we have to increment 2 to 4. Now we found the hash, ignore it. We found a comma here. So we have found another node, which is hash. So let's decrement 4 to 3. But this node hash basically represents the null value, which is this, and it does not have any of the left or right children, so we will not add 2 here. Now again, we found a hash here, ignore it. Now again, we found a comma and decrement that from 3 to 2. Now we have found 1 here. Now just ignore it, and for this comma, let's decrease 2 to 1 and increment the value 1 by 2, which is 3. Because this 1 is a valid node and it can have 2 children. So now we are at this position hash. Let's ignore. Then this comma, we have to decrement 3 from 2. Now we are at this hash. Let's ignore. Now we are at this point comma and decrement 2 to 1. Now we are at this point 2, so let's ignore it. Now we are at this point comma, that means we have found a node here. So first decrement 1 to 0, then add 2 here. Now we are at this node, which is hash. Let's ignore. Now we are at this point, which is comma. So let's decrease 2 by 1. Now we are at this point 6. So just ignore. Now we are at this point comma. So here at first decrease the value 1 to 0. And after that increment by 2 because it is a valid node and it can have left or right children. So 0 will become 2. Now we are at this point hash. So let's ignore. Now we are at this comma. So decrement 2 by 1. And I forgot to mention one thing. We have to add a comma after the given string. So this is the last comma. So this one will be reduced into 0. So here, after the simulation, we have found that the node value becomes 0 if the given tree is the valid binary tree. And the overall time complexity of this problem is big O of n, and overall space complexity of this problem is also big O of n. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named isValidSerialization, which has a string preorder and initialized our value nodes with 1 and added a comma after the given string. Now we are running a loop from 0 to the size of the string, and here if the current character is comma, that means before that we have found a node, so we have to decrement the node value. And if in any of the case the node is greater than 0, we have to return false. Otherwise, we have to check if the value before this comma is equal to any of the digit or not. That means if the preorder of I-1 not equal to hash. If it is, we have to add 2 to the node value. Finally, if the node value is 0, we have to return true. Otherwise, we have to return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.